Hello everyone.
Good evening, sir.
Yeah, good evening. Okay, we will discuss week 10 content. So, anyone who know what is in week 10? So, okay. So, till week 9, we discussed what?
Random variable.
Yeah, and then last uh, topic is PML, and after that CDF, right?
Yes, sir.
Yeah. So, what is CDF?
Cumulative distribution for
Function.
frequency.
No, no. Cumulative distribution function. Yeah, you can
Okay.
say frequency. Yeah. No. So we know what is the cumulative distribution function for discrete case, right? It is what? F of x equal with probability of x taking value x. Oh, sorry, x is less than, sorry. This is, yeah. PMF is for discrete cases. P of x is probability of x taking x. CDF is same both for discrete and continuous for both cases. Okay. Now we will see what? Today we will see expectation. Okay. This is generated by this. Okay, then just a second. Yeah, first we will see expectation of random variable. Okay. After that, what we will see variance. Variance of random. Okay. So what is the expectation? What is expectation? Okay, we will see. So you know what is mean, right?
Yes, sir.
So mean is what? If I roll or die, assume that I am rolling continuously die as in 10 times, okay? And I got result like randomly 1, 3, 2, 6, 4, 5, 3, 2, 5, 4. 1, 2, 3, 4, 5. Okay. So now I want to know what is the mean. So how we find mean?
Sum of all observation by total number of observation.
Yeah. So which is what? 1 plus 3 plus 2 plus 6 plus 4 plus 5 plus 3 2 plus 5 plus 4. Now divided by what? Total number of observation. Okay. Now I can split this sum as how many times one occur? Only one. One. Yes. How many times two occur? One and two. So 2 into 2. Yes. How many times 3 occur? 1, 2 into 3 into 2. Now, similarly, how many times 4 occur? 1, 4 occur. How many times 5 occur? 1 and 2. So 5 occur 2 times. And how many times 6 occur? 1 time. 1, no, 6. Right. Okay. So if you see, so I can write like this. Now assume that if I toss roll a die infinite time continuously, so what is the probability that one occur in the infinite case?
I expect that if I am performing same experiment n number of times,
Yeah.
then the probability should be same if I perform the same experiment infinite number of times. So it
What
should
is
be
the probability? No, no, I'm asking about probability. What is the probability that one occur at that case?
that's it's
It's
one
1
by
by 6, right?
yeah, uh, of a dice, no?
Yeah, die.
Yeah, 1/6.
Yeah. So now, so this means one occur, probability of one occurring is what? 1 by 6, right? Same as probability of two occurring.
Yeah.
Yes, sir.
Yeah. 1 by 6, 3 by 6. Probability of 6 occur is 1 by 6. Okay. In the
So
fractional case, if I divide this, this is 1 by 5, this is 1 by 5, approximately 1 by 6. 1 by 5, 1 by 5, this is here in 1 by 10, 1 by 10. Okay. But in infinite case, this fraction goes to this term, right? Same this, same this. Because each have equally probability, equally likely. Right?
So
So
why like what's the logic of treating the value of expected variable as the weight?
weight,
When yeah, it's like expected variable times the probability, na?
no, no, no.
Value of
See,
expected variable
see, your random variable taking values like what? 1, 2, 3,
up to 6.
up to 6. Okay,
Hmm.
now expected value means if you what is the probability, what value we most of time came most of the time,
Hmm.
right?
Yeah,
So one occur, how, what is the probability that one occur?
1/6.
So one occur into 1 by 6.
So this thing I'm asking, like
Yeah,
why?
that this is by this sum. Assume that you in sampling case, what we did our sample, how many sample we have. Okay, assume that this is my 1, 2, 4, 6, 6, 5, 4. Like this, I have large sample of rolling a die. Okay.
Okay.
Okay. Now, what is the mean?
Mean is like summation of all these things divided by
Okay.
the
Yeah.
number of observations.
Yeah. Exactly. So if I take all the ones, then I have some factor
Mhm.
which contain n, and our how many times one occur. Yeah.
Yeah,
Which is what?
which is the probability.
Probability of that one occur.
Yeah.
Yeah. So which is what? 1/6.
Hmm.
Okay. See this in infinite case.
Hmm.
Yeah. Same as 2 occur. How many times 2 occur? It will be assume that x, then 3 occur. Yes. 3 occur x. Okay. This is x1. This is x2. This is x3. Like this, I have 6 occur x6 time. Now divided by total number of time. Okay.
Yeah.
Now 1 divided by x1 divided by n plus 2 x2 divided by n. 6 x6 divided by 6 n. Sorry. So this is what? This is probability of x
X.
equal to be 1.
Hmm.
This is probability of x equal to be 2.
Yeah.
Same as probability of x equal to be 3.
Hmm.
No, okay, 6. Okay.
Yes, sir.
Now you got the idea of for expectation.
Yeah.
So
Sir, your screen is not
But
visible. Sorry about that.
what?
Your screen is not visible.
Which screen?
it's visible for me, sir.
Visible, sir.
We- I think I should rejoin them. There's some network issue. Sorry about that.
Okay, maybe, yeah. Try to connect it. Okay. Now, if you have random variable in the discrete sense, assume that this x is the random variable which takes values what? X1, x2, like xn. Okay. Then what is the expectation? Expectation of x is what? X1 probability of x1. Okay. Plus x2 probability of x2 occur. Like this, xn probability of xn occur. Any doubt in this?
No, sir.
So this is can be written like this probability of xi. This is your formula for expectation. Now you have idea that how we get this expectation. So mean is the counterpart of expectation in sampling case, and you can say vice versa. So, expectation is the counterpart, same part of similar to mean. And so if there is any probability, concept of probability, if in any question, then question ask about your expectation. If there is no probability in the sense that you have sample, and then there is no expectation, then there is mean for that. Okay.
So,
Yeah.
like, what type of behavior are we expecting here to be the for the x for the random variable? Is it like a finite set, still a countable
No,
finite set, or it can be countable infinite set also?
it can be countable infinite set. Then this summation goes to infinite. Okay.
Okay.
Yeah. Same concept.
Okay.
Now, so yeah, can yeah, I have slides. Just a second. Just Yeah, now you can see. So if you see this example, so there is a die which is rolled 100 times. Okay, these are the observations. Okay, 1, 5, 4, 6, 4, like this. Now we will see what is the frequency of this. So outcome 1. Okay, now we have what? Yeah, we have some game. If in die 1 come, then you get +1. If 2 come, you get -2. If 3 plus 3, these are the payoff. Okay, payoff for that game. So this is representing a random variable. Random variable like x of 1 is what? 1. X of 2 is -2. X of 3 is -3, like this. So this is payoff for that game. Okay. Now we roll. Now we want to know what is the expectation of this random variable. Okay. This means what? What is the expected payoff for this random variable? Which means if you play this game again and again, then most of time, what is the frequent payoff? Okay. Now see, if you see this data which is given, so 1 occur how many times? 16. 2 occur 10 times. 3 occur 16 times, like this. Now this is the frequency which is given. Now we want to find what is the average, what is my average payoff. So if you see how to find average payoff, this into this, either you can write like 1 plus 1 plus 16 times, -2 -2 -2 10 times, plus 3 like 16 times, then divided by total number of observation, you can get this number. Or you can do what? This into this, -2 into 0 point, which is what? 1 occurring 16 times divided by 100, total number of observation. Okay, it is like this, right? So 1 occur how many times? -1, 1. 1 occur how many times? 16 times. Okay, then -2 occur how many times? 10 times. Then 3 occur how many times? 16 times. Then 4 occur, -4 occur 21 and 23. So -4 occur 21, 5 occur 23, and 6 occur how many times? 6 occur, -6 occur 14 times. So -6 occur 14 times. Divided by total number of observation, which is what? 100. Now it can be write like what? +1. 100 divided by 16 divided by 100, which is frequency of getting 1 in die. Similarly, -2 is 10 divided by 100, which is frequency of getting 2 in die, like this, which is, and frequency is associated with probability. If you repeatedly roll your die, uh, then this number converges to your probability, which is 1/6. Okay, so by this you can also see what is mean by expectation. So expectation meaning is what? -0.09. This means if you play this game again, then most of time you get this payoff, means you are losing. Now rolling 1,000 times, this is the data. 1 occur 177, like this. This is the frequency. Okay, now what is the average payoff? Same. No, so not so, sorry. Yeah, average payoff is this. Now Okay. Now, as you increase your number of rolling, see this goes to here. Now, if you increase your rolling times, then these frequencies goes to where? 1 by 6, 1 by 6, 1 by 6, like, right?
Yes, sir.
Yeah. So now you can find, now uh, try to solve this and find the what is the average winning in this question. Yeah, for try to find random expectation of this random variable. Random variable is what? One taking plus one value, two taking means x of one is x of one is one, x of two is, okay, just x of x equal to be x if x is odd, minus x if x is even. This is your random variable, and random variable x is what? X belongs to be 1 to 6. Okay. Now try to find the expected value. Means what? 1 into 1 by 6 plus minus 2 into 1 by 6 plus 3 into 1 by 6, like this. Try to find and tell me what is the number. Yeah, see, if you say the relative frequency of each of the 6 possible outcome is close to the probability of 1 by 6 of respective outcome. Okay. Yeah. Yeah. Answer is this. Okay. This means your average payoff is minus 0.5.
5.
Yeah. Okay. Which is close to what? If you see, when we roll die 1,000 times, we get what? This, which is close to minus 0.5. Okay. Let's see. Just a second. Okay, just a second. What will just a second. I have to change. Okay. Okay, now am I audible?
Yes, sir.
Yes, sir.
Okay, now you know what is the expected. No. Can you find what is the expected outcome? Okay. Now I have one question. Yeah. If my random variable experiment is I am tossing two die, rolling two die, and random variable is what? X, x1, x2 will be sum of output plus x2. Can you find what is the expected value for this? Till then I can draw some graph.
So 2 to 12
What?
values for x1 plus
No, no, no.
x2.
Expectation of x. This. So what is the answer? So answer is
Seven, sir.
7. Yeah, 7, which is what? 2 into probability of getting 2, which is right,
1 by 36. Yes.
plus 3 into how many times 3 occur? This sum occur 2 times. Okay. Like this. Okay, 7, which is what? 7. This column, and this is the graph of your probability of mass function. Okay, so expectation give you what? The value which occur most of the time, which is 7. Okay, if you roll your die and you if two die and sum the outcome, then most of the time you get 7. Okay, so this is the fact. Now you can use this. Okay, now when we have one, okay, this is
So one query I have, like, when we are from the first slide of this week 10, that is when we are performing, like, when we talk about some this experiment,
okay.
uh, it and just a the slide says that a random experiment, the question, it is the we are interested in analyzing the number of credit cards owned by people. Towards this, we
Yeah.
collect data on the number of people and asked them how many credit card they own, and
Yeah.
their response is recorded.
Yeah.
In this case, random experiment is noted as consider the random experiment of selecting an adult at random from the sample.
Yeah.
Now, my question is, sir, here is that we are choosing some random person from the population or from the sample. Because that's how we define the sample. Now we are choosing some random persons from the population and constructing
No,
a.
no. Can you your question? Repeat your question.
Okay. Uh, the case is we are interested in analyzing the number of credit cards owned by people.
Okay.
Towards this, we collect data on a number of people and ask them how many credit cards they own,
Yeah.
and their response is recorded.
Yeah.
In this context, a random experiment is considered as selecting an adult at random from the sample.
Yeah.
So now
So
here my question
yeah,
is,
we are selecting sample from data in sample because see, because we only I have population of, see, there is some child, there is some student, there is some big class of dot category which is adult, and there is some older people. Okay.
okay,
Now I'm not uh, observing these child, student, and these things. Okay. I'm
hmm,
only concentrated in adults. Okay.
okay,
Now I take this as my sample, then I randomly select. Okay.
okay,
If I randomly select from this whole population, then I can select a 1 year old child also. Okay.
okay.
So my experiment is uh, not
So,
good in this
so
case.
context given was we are interested in analyzing the number of credit card owned
Yeah.
people, but
People.
such division was not mentioned in the context.
But question mentioned that we adults, I think question mentioned that they are observing only adult.
Random experiment it's mentioned, not in the
Ye-
context they
no, no,
explain.
if you repeat your question, you mention that adult is uh, from the population, I think.
Okay. Let me share the screenshot of the same in the chat.
Just second, I have said, just I just we are interested in analyzing the number of credit cards owned by the people. Towards this, we collect data. Yeah, they collect data only from those people. Data on people and ask them to. In this requirement, we are interested in analyzing owned by the group. Towards, yeah, they have. So they already have some data, na?
Their response is recorded.
Yeah, they already. Then they are selecting random.
Okay. Means
Yeah,
first the data is collected
yeah.
and that
Then they
collection.
are selecting randomly.
Okay. This data collection is happening for a population or it's operating for or happening for a sample.
It depends on, in this case, if they collect data from child, there is no
Okay.
make sense.
Yeah, okay. Hmm.
Okay, that's why
Mhm.
maybe they can include student, they can include adult, and they can. I think older people are also, yeah, they can include, but so they specify some. They have some objective. Okay.
Okay. Okay.
Yeah.
Means first sample is constructed. Means the concerned
No, no,
entity.
there is no sample. The data they collect, collect some data, which is the whole population. They observing the for those guys, population is not full. All the people they only they have that same population is only the data that they have. Okay.
Okay.
Yeah.
Okay. Means the complete data is treated as population.
Yeah. This is the population.
Mm-hmm.
Yeah.
Okay. And
Now
now,
by using this, they they perform some statistical tool, and then they infer about the whole population. Okay.
Okay, means but this inside the box, that the population, that is the data that they have collected
That they have, yeah.
considered as population, but as a
For
part of the
that, for that,
credit for them, and
yeah,
for that a sample is constructed from this population itself, that is studied, and that infers from the for the larger population.
yeah.
Okay.
Okay. Now what we have? So yeah, we have what? Firstly, uniform random variable. Before that, what? Bernoulli. Yeah, Bernoulli.
So one question here more, like it's saying that selecting an adult at random from the sample.
Yeah,
If we are treating this the collected data already as a population, then that is a limited number of or content number, a limited number of data that we are having.
yeah.
So why are we still selecting randomly from the sample?
We can't
Uh,
select whole sample now.
इस sample is analyzed completely, तो sample में तो हम पूरा ही select करेंगे ना?
No,
एक
no, no. Then that experiment is not random.
Okay, just a second. Random. Yeah, got it, got it. That is talking about the relation for a particular person in that
Yeah.
context. Yeah.
Now what we have? Yeah, Bernoulli random variable. So what is the Bernoulli random variable?
When we have just two and coded as like 0 and 1,
Yeah.
the the random variable.
So random variable only take value 0 and 1. Okay. If 0 when a event A happen, not happen. A not, and 1 when A happen. Okay. Okay. Now this means what? This is A not happen means A complement happen. Okay. Now what is expectation in this case?
That's going to
Firstly,
the
what is the probability? Firstly, we have to be associate some probability for these random variable. So what is the probability of x taking value 1? Let's say this is P. Okay. Assume that this is a die case. Sorry, die. Coin case. So when head, then 0, when tail, 1. Okay.
okay,
And,
so
yeah. Now what is the probability that tail occur? For
probably
unbiased die, we have 1 by 2.
that's 1 minus p.
But assume that this is P. Now what is the probability of head occur? 1 minus P, right? Now
Yes,
what is
sir.
the probability? What is the expectation? Expectation of x is what? Firstly 0. Okay, firstly 1. 1 into probability of x occur, which is P. Okay. Plus 0 probability of 0 occur, which is 1 minus P. Okay. So what is the expected value? Right?
Yes, sir.
Yeah. Which means what? If probability of head occur, okay. Okay. No. Yeah. Now I have another random variable. So these are the some useful random variable for further course. Okay. The other is uniform. What is the uniform? We already see what is the uniform. We have die. What are the outcome we have? These, right? And what is the probability for each outcome? 1 by 6, 1 by 6, 1 by 6, right? So which means what? Each outcome is equally likely. Same case, if I have n observation like x1, x2, xn, then a random variable taking values this, then this random variable is called what? Uniform. If each have probability same. Now why this 1 by n came? Assume that x1 have probability p. Then according to the uniform, x2 also have p. All have p probability occurring. Right? Then what is the sum? Sum of p from I equal to 1 to n is what? 1. We all know by second property of probability axiom. Then by this we can say what? P into n is 1. This implies p is 1 by n. Okay. If I have n outcome, then what is the probability of each outcome is 1 by n in case of uniform. Okay. Okay. Which is which you can relate with your die case. Now, what is the expected value here? What is the expectation of this random variable? So expectation is what? If my random variable taking values 1, 2 like this, and then what is the expectation? Expectation is what? 1 plus 2 plus 3 and with their probability which is common, so that's why I divide n. And we all know what is the this sum, n plus 1 divided by n, 2n, this 2 from this n from here. Now if I divide, this is okay. And out.
No, sir.
Now next random variable is what? Okay, till now we have expectation, we have Bernoulli P, Bernoulli random variable with probability of success. Okay, yeah. Here you can relate 0, 1 with 1 is success and 0 is failure. Okay. So Bernoulli P means probability of success is P. Then probability of failure is what?
1 minus p.
1 minus. Okay. Now what we have? Okay. After that, what we have? Uniform.
Let's see.
Uniform with n. N means number of total outcome. Okay. These are the parameters. You will see discuss this in later course. So these are the parameter which if someone told you I have you have some Bernoulli random variable with p, then this define your random variable. Okay. Depend on p. If p is 1 by 2, then you know this is the coin case. If p is 1 by 4, then this is another random Bernoulli random variable. So these are the parameters. Okay? Yeah. Now what we have?
So in Bernoulli's, are we only restricted by the value of 0 or 1, or we can encode any some x that is random variable as 0 and 1 for some purpose?
But
Are in Bernoulli's variable, there's
yeah.
are we restricted with the value of 0 and 1 only, or we can encode like head and tails as 0 and 1 and then go for Bernoulli's random variable thing?
Head and tails and you are saying that if I use another script instead of 0 and 1.
No, no, I'm saying like for the case of like head and tails,
Yeah.
if I encode it as 0 and 1, then can I still use the Bernoulli's random variable?
Yeah.
Okay.
So if you have head with probability p and tail with probability 1 minus p, then your random variable x take h and give what? Assume that one, and tail with 0, right?
Yeah.
Yeah, this is the Bernoulli.
Okay.
You can find expectation, but that expectation that expectation you got, it's not like that expectation. Since you got expectation of x is what, p,
Yeah.
right, which is
Hmm.
not associated with these h and t, which is associated with what?
Large number of means experiment
No,
learn
no,
on
no,
the.
no. These are associated with these 0 and 1. So assume that you have one game. If head came, you get 1 rupee,
Hmm.
and if tail came, you get nothing.
Hmm.
Okay. Then
Okay.
what is the expected amount you get?
Hmm.
This is that p. Okay.
So, but still, can I not like if I get for the same thing, expectation for this hat and tails,
Yeah.
say it's coming as like zero point 0.2, okay?
Yeah.
S- it's still inferable. Is it not right to infer it like if I toss 1,000 times, then I'm going to get zero point 0.2 into
Yeah.
1,000 times head.
Yeah.
So I think we can still infer about head and
Yeah. We
tails.
can infer, but in most of cases, assume that if this is happen, -1 instead of 0, we have -1.
Okay.
Okay. Then what is our expected value? P minus 1 minus
Minus
p.
P. Yeah.
Right. Then what is
That
the value which I
one.
get?
2p minus 1.
2p minus 1.
Yeah.
Now, what do you say by this? Is this
Mm.
head or tail?
So encoding is the 1 and minus 1. So
You can say if this by this if the expected value of now yeah, what yeah, you can say what, assume that this is 0.2. From here you can get what value, p value you can get.
yeah, probability we can
Now you
get.
can say that what is the probability of head k, which you already know.
Mhm.
Yeah.
Okay.
So these expectation are about random variable, not about that head and tail. Okay. In this case, these are, you can say that these are, I can infer, but there are many there are random variable which take many values, more than two values. Okay.
Mm. Okay.
In that case, it is difficult, and basically random expectation is always defined for random variable. Okay.
Okay. Mm.
Yeah. So makes assume that you are playing some game and your random variable gives you payoff of that game, means x i's are your payoff, that you choose that ith condition. Okay. And then what is the expected value you get, expected payoff you get, you can relate this. Okay.
Mm.
Yeah.
Okay.
Yeah. Now what we have, okay, now we have one important theorem which is called lotus. Okay. And I forgot the full form of this, but this is law of for stat. I know, but what is the meaning of this full form? Yeah, it says that means statistician know that use this formula, that expectation of gx. They use this formula, but they don't know how they get this formula. That's why this is called lotus. And yeah, search what is the full form of. You can try. Yeah. So the proposition is what? Assume that x is our random variable, and it is also true for continuous case also. But we are in discrete, then that's why we will discuss this discrete. So x is my discrete random variable, which is taking values what, xi's, along with some probability mass function, which means p of x I this. Now we have another function g of x, which is function from a range of x to r, real valued function. Okay, then expectation of gx is what? Summation gi probability of x equal to bx. Okay, 1 to n in this. If x take finite value or n, if x take infinite value, then n is infinite. Okay, any doubt? So we have one random variable discrete. For that we have PMF. Now gx is the real
Sir,
value.
can you explain once again?
Yeah. So this thing, search in Google after this class. Why this is called lotus and this. Okay. Now I will explain this. Now x is our random variable which take values x size. I is 1 to infinity or 1 to n. It's up to you. Then we have PMF of x. This is PMF of x. Then I have some real valued function which is gx. So gx is my real valued function. Then what is the value? So now x is random variable, then gx is also random variable because it maps. What is the definition of random variable? Random variable maps my sample space to real value. Same thing happening here. If you see this, g of x is what? Composition of what? G o x. Now you put some value from sample space, it will give real value. Okay. So gx is my real valued function. Then what is the expectation of gx? Which is the given by this formula. Okay. Why this formula gave? It is the measure theoretical part, means uh, theoretical probability part. So we will not discuss that. Okay. Now any doubt? We will solve some question for that.
Okay, sir.
Yeah. Let's see some question. So x is the random variable which takes value what? -1, 0, and 1. And probability of PMF is given by that. PMF is 0.24 minus 1, 0.540, and 0.3 for 1. Then I have gx is the function such that gx equal to be x square. Okay. Now what is the expectation of gx? Can you find? Try to find this. Yeah, law of unconscious states.
0.1.
Yeah, answer is yeah. Someone already mentioned what is the full form of lotus. Okay. Now, what is the answer? Let's see. So, what is the formula? Formula is summation g of xi probability of x equal to be xi. Right. So, first x is x take -1, then g of -1 probability of getting x equal to be -1, plus g of 0 into probability of x getting 0 plus g of 1 probability of x equal to be 1, which is what? Minus 1 square into 0.2 plus 0 into whatever 0.5 plus 1 square into 0.3, which is what? 0.5. Okay. Any doubt in this?
No, sir.
Okay. Now, can you find expectation of x square? This.
Sir, 0.25.
0.05.
0.25.
0.25 for x. Let's see. Minus 0.2 plus that 0 plus 0.3. What's the answer? 0.01. And then square of this is what? Okay, sorry, 0.1. The square of this is what? 0.01. This is the answer for expectation of x square. Okay. Now, are they equal? No. So, expectation of x square not equal to the expectation of x power. Okay. Now, see, what is our x? X is what? Minus 1, 0, 1. Right? Now, what is our y? Y is our gx, which is what? X square. Now, which value, what is the value that y takes? Minus 1 square is what? 1. Okay. And 0 square is 0. This means y can take only 0 and 1. And when y take value 0, so y equal to be 0, this means what? X square equal to be 0. This means x equal to be 0. This means what? Probability of x y equal to be 0 is what? Equal to probability of x equal to be 0. Right?
Yes, sir.
So probability of x equal to be 0 is 0.5. Now what is the probability of y equal to be 1? Probability of this. This means what? Probability of x square equal to be 1. This means what? Probability of x equal to be plus minus 1. Right? And what is the probability that x take plus 1 and minus 1? This is 0.2 and plus 0.3, which is 0.5. So gx is the another random variable. For that, probability mass function is this. Okay. Okay.
So could you scroll a bit, please?
Yeah.
Please. And yeah. Okay, got it. Thanks.
Okay. Now what we have. Yeah. Now we have. Okay. Now what is the expectation of sum of random? Expectation of x plus y. Yeah. X is the random variable, y is the another random variable. What is the probability for? What is the expectation of this?
So what is y?
Y is the another random variable. So this is expectation of x plus expectation of y. Okay. Okay. Now okay, just a- okay. I think in your course there is no proof for this, okay? Right? Or they mention. Okay. Let's see some question after that. If there is any proof, then we can ask. So expectation is linear in sum. Okay. Means if you have two random variable x and y, then sum of expectation is sum of expectation of sum is sum of expectation. Okay. Now I have one random variable, which is important. I think most of the important random variable. Before that, we have, I think. Okay, let's discuss firstly. What is a binomial random variable? Binomial NP. These two are the parameters. So, you know what is the binomial random variable? Anyone know? So, binomial random variable is you have some experiment and you are doing n trial of that experiment. Experiment is like which have result like 0 and 1. Okay, means Bernoulli experiment. Okay, and you are performing that experiment n time, which means you have n trial. Okay, then what is the success that means if x is the Bernoulli random variable, then it gives number of success. Okay, okay, so this means probability of x taking value k is what? This means in n trial we have k success, right? And each trial has probability of getting success p and yeah, failure 1 minus p. Yeah,
This success is coded as one now, like
yeah,
one of
yeah. So what is the probability of that k success are happening? So firstly I have to be choose that k success. So then nc k, right? Then I have k success. This means one success k to the p to the power k, and I have how many failure? N minus k with probability this. So this is the formula for binomial model. Okay, with parameter n, which is the number of trial, total trial, and p is the probability of success. Any doubt?
Could you please explain this a bit more, sir?
Sir, NK is same as N choose K.
Yeah, NCK is the NCK, probability of getting success and probability of getting. Okay, you need, okay, mode of derivation. So assume that you have some experiment with success and failure. This means your random variable taking values 0 and 1. 1 and 0. Okay. Success and or failure. Now we are asking about what? X is our what? X is number of success. Okay. Then X take value K. This means what? I have how many success? K success. And these cases are one of the, I have total N. Then I have to be choose that K success. Okay. How many ways I can choose? NCK, right?
If I
And
have n successes and I
no,
have
no,
to
I have N trial, not success. Sorry.
okay
I
and
have K success and N are the number of trials. Okay. Means number of time that experiment is happening. Okay.
okay.
Again, again. Then out of N, I have K success. This means I have to be choose that K points where the success happen, which is NCK. Then you can relate this by what? I assume that I have die, I roll die N times. Okay. Then I have K success means I have K hat. This means NCK, I choose NCK. Then what is the probability of that one head occur? P. What is
So
the probability?
one thing as we are proceeding this, we are repeating an experiment n number of times.
Yeah.
So our order also matters. So why are we going from from a combination thing? We should go with the permutation thing, no?
Which order?
Uh, that what I'm saying is when we are performing the experiment first times,
Yeah.
then second times, then third times.
Yeah.
So so on. So orders matter.
Yeah.
Because order matters, we should go with the permutation or the combination.
Mhm. See, if I choose permutation, this means what? Second means assume that this is my points 1, 2, 3 like n. Okay.
Yeah.
I first time, second. If permutation is matter, then what is happened? 2, 1, 3. This means what? First success come at second place, then second success come at first place, which is not happen. This is same as 1, 2, 3, right? First success, second success, third success.
It's you said the success and failure is coded as 0 and 1.
Yeah, yeah.
So if I write it like 100
Okay,
and then
1, 0, 0 and
yeah,
0, 1, 0.
yeah, both are different.
Both are different.
Yeah.
And these are counted as different now.
Yeah, both are counted as different. So order
Assume
matter.
that I have a string of, yeah, string of what? 0 and 1. And I have K success. So how many places that one can be occur?
K places.
K places. And how can I choose that K places?
That K places. Yeah, yeah, yeah. Got it now.
Okay.
Yeah, yeah. Got it. Got it.
So NCK, then probability of K success occur is what? P to the power K
Hmm.
into 1 minus P to the power K, that N minus K failure. Okay.
Mhm.
This is the formula. Okay.
Yes.
You have to directly use this formula. Yes. Okay. Now what we have? We have hypergeometric random variable. Actually, I think they didn't discuss this Bernoulli in your that slide. They directly discuss hypergeometry. Okay, hypergeometry. Now we have what? Hypergeometry. So, okay. Yeah. So, hypergeometric is what? Is number of so you have what? N sample size means in sample space you have an outcome. Okay. You choose one what? One outcome from this N. Okay. We will discuss with this by example. So assume that this is the bucket in which M are red ball and N minus M total are N ball are blue ball. Okay. Then what is the problem? And my random variable is what? Number of red ball. Red number of there. So what is the probability that X take value K I? What is the probability that X take value I? I is the number of red ball in selection.
That's going to be M choose I. That is one thing. That is number of uh, red balls that we have times then it's then it's going to be n minus m choose um uh, how much we choose I. That is
Okay.
so
No,
what
just
we have total n number of balls, no? Small n.
no, just we have total capital N number of balls,
Okay.
and I am choosing N from this. Okay.
Okay.
Okay. So I have total N, and I am choosing N balls without replacement. Okay. I choose first, second, and like this. Okay.
Okay.
Then what? Then X is the random variable which denote number of red balls in this N balls which I choose.
Okay.
Yeah. So what is the probability for that? How can we find?
It's like choosing the red balls. So choosing the red balls is m choose small n.
Why small
No, no,
N?
I'm choose
I
m
have
choose I.
only I. Yeah.
Choose I. M choose I. M choose
Yeah.
I.
Yeah.
We are talking about this. Then it is going to be n minus m. Choose uh, n minus I.
Which I? Small capital.
Small n minus I.
Yeah. Then
Whole
we have
divided
what?
and choose capital N choose small n.
Yeah. So this is called hypergeometric random variable. Okay. So what we have? We have X is the random variable. Firstly, we have what? We have N balls. Okay. Out of which I am choosing N, and in out of these N I have M red ball, which I can say M, if I'm right, assume that these are M success. Okay. And I have other are failure. These are failure. Okay. Then
Okay.
X is what? Yeah, I am choosing n from this n. Okay. Now, what is X is number of, assume that X is number of success. Number of success in n. Okay. Then what is the probability that X take value I is what? Total I have m success, out of which I choose what? I. This means other R came from what? Failure divided by total number of. Okay. So when you use this hypergeometry, we use, if I have some my sample space and there is some part which is success and some part which is failure. Okay. Then I get, and I am choosing some n sample from this, and my random variable is number of success in this n. Then I can use my hypergeometric. Any doubt in this? Any doubt?
So, could you help differentiate when to use this binomial and when to go with this hypergeometry? Hypergeometry got an idea like when we are choosing n from both this success and failure thing.
Yeah, I choose some n like this.
Yeah,
These are the n. Okay.
yeah,
And what is the, yeah, in binomial case, what we have? Binomial case, I have some experiment. I am performing this experiment n times.
okay. Means same experiment is repeated
Yeah,
and
same time. And one experiment have result 0 and 1. Okay, success and failure.
okay,
Okay, success and failure. Then what is the probability that and then X is denote what? Random variable is denote number of success in n trials. Right?
okay.
Then X take value I. This means what? In
Mhm,
this n time that event performed, then I get success in I.
yeah.
Then this means what? NCI, probability of I, probability of getting success in I times n, 1 minus P, which is n minus I. Okay. So Bernoulli is defined by what? Bernoulli NP, and it denote your number of time that number of trial, means number of time that experiment performed, and P is denoted what? Probability of success. Okay, in one trial. And
Okay,
each trial have same probability because same experiment each trial. Okay. Now in case of hypergeometry, in case of hypergeometry, what we have? We have, what are the parameter with what we have? We have n, which is total number of outcome in the sample space, out of which what we have? Small n, which denote how many outcome I choose in one time,
okay.
means sample size.
Hmm.
Okay. Then what? I is what? Number of success. So in n, mr is what? M is success and n minus m is failure. Okay, so what are the parameter we have? We have what? N, m, then small n. Yeah, these are the parameter and I is the function. So these are the total number of outcome. These are the total success we have. These are the total sample size, and this denote what? Success in this sample. This can be changed, but these cannot be changed. Okay.
Okay. Capital N is the total population, that population size.
Yeah.
M is success.
Total number of success in population.
Yeah, and N is the sample size that we are taking.
Yeah. Yeah.
Okay.
Okay. Now I have some question related to this. So two students are randomly chosen from the group of 20 boys and 10 girls. So we are choosing what? Two students from 20 boys and 10 girls. And X denote what? Number of boys chosen. Okay. And Y is what? Number of girls chosen. Okay. So firstly we focus on X. Okay. What is, so I have some sample that my sample space, which is what? 30, right? I have total 30,
Yes, sir.
20 boys and 10. Then what is N? Capital N.
30.
30. Now, what is success for X? Choosing a boys is success.
It's 20.
Yeah. So what is the M? 20. Because for X, success is what? Choosing a boys. Now, what is N?
N is 2. We are
2.
choosing sample of 2.
Yeah. Yeah. So now you can find what is the expectation and all these things, because you know what is, this is the hypergeometric random variable, and what value it will take. X can take what? 0, 1, 2.
Yeah.
Yeah. And what is the probability associated with this? Because you can find by this hypergeometric formula, this formula. Yeah, this formula. Okay.
So, sir, will this hypergeometric formula give the same result when we are adding for x equals to 0, x equal to 1, and x equals to 2? Will
X
the
equal
result of the both this calculation be same?
means I don't understand you.
Well, means I'm saying that number of boys chosen
Yeah.
is like choosing no boy, that is 0 number of boys,
Yeah.
then it is 1 number of boys, then it is 2 number of
Yeah.
boys.
Yeah.
These three are disjoint sets. So if we are saying that expectation of x we are calculating, then
Yeah.
it's going to be expectation of 0 by selecting, choosing 0 by,
Yeah.
plus expectation of 1
Yeah.
by choosing 1
Yeah.
by.
Same. I already discussed this now. I also discussed this now. How to find this expectation? X take value 0, 1, 2, then 0 into probability of X take value 0 plus
Yeah.
probability of 1 into same. There is no another way to calculate expectation. Yeah. Okay. Now, oh, for that I didn't discuss what is the how to find expectation of uh, hypergeometry. So firstly we discussed that.
Yeah,
So what is,
I was thought I thought that whatever we are calculating for hypergeometry, that should be same as this calculating that individually, because both are like same thing.
yeah, so just it. What is the probability of X taking value I in case of hypergeometric is what? NCI into n minus m c NCI divided by NCI NCN. So then what is the expectation? Expectation is what? 0 into probability of X equal to be I plus 1 into probability of X equal to be okay, this is not 0, this is 1. Write this, okay? And if you solve this terms, try to solve in homework, then you get what? NCM divided by n. This is the expectation of hypergeometric. Now you can find expectation of X, which is what? N is what? 2 into what is M? 20 divided by N. What is the, which is 30? Which is what? 4 divided by 3. Now what is the for x, for y, what is n? Firstly, what is the success for y? Choosing a girl. Okay, this is the success for y, right? Then what is n? In example, what is n?
30, sir.
Yeah, 30. Then what is m?
Is 10.
Yeah. And what is n? We already know. Now by using these parameter, you can find probability associated with hypergeometric. Okay. And what is the expected value of y is 2, which is n, into m, which is 10, divided by total number. This is 2 by 3. Okay. Now what is the, now what we have? Yeah. What is expectation of x plus y? Firstly, what is x plus y? X is number of boys, y is what? Number of girls. Then x plus y is, what is x plus y?
So, could you scroll a bit up, please? In this thing, expectation of x that you just wrote that it's nm by capital M,
Yeah,
capital. So is it like if we are going to this hyper this expectation calculation,
yeah,
or we go with like expectation of 0, 1, and 2?
yeah.
This is
Same,
like
same.
same path.
Yeah.
Mhm.
This, see, this is come from formula. I'm just using formula. You are saying that if I go from formula and if I directly use this, both are same.
Okay.
Yeah.
Mm.
Well, now what is the x plus y in this case? X is the number of boys and y is the number of girls. Then what is the x plus y?
That's 30.
No.
If,
See, I
yes.
am choosing two from that 30.
Mm.
Then what? And from this, x denote number of boys, y denote number of girls. See, this is the hypergeometric now. So you
Yeah.
have some sample space, then there is some success, out of which we are choosing some sample. So
Yeah.
sample of size is what? 2.
Yeah. 2.
Then what is the x plus y?
It's going to be 2.
Yeah, that's because x denote number of boys. If both two are boys, then y takes value what? 0. If both two are girls, then x take value 0. If one is boys, then another is one is what? Girl. Then x plus y is what? 2. In all cases, x plus y takes value 2. Then what is the expected value of 2? Expected value of x plus y.
Mm.
It's true because x taking always 2 value now. No matter what happen, x is always 2. This means what? No matter you lost or uh, you gain, you always get 1 rupee. This means what? Your expected payoff is always 1 na.
एक second now. X plus y. s- It's x plus y. So x plus y is 2. Okay.
Yeah,
Means now we are seeing the expectation of the same, or what?
yeah. So
Okay.
expectation of x plus y is what? Expectation of x plus y saying that but which value you get most of the time. If you always get 2, then what is the expectation? 2, right?
Mhm. Okay.
point.
And you can check this by what? Expectation of x plus expectation of y formula. Okay. If you put, you get same answer too. So always remember that expectation of constant is always constant. Okay. That's C. C is constant. Okay. Because if you always get this C in losing and winning, this means no matter what will be the happen, what will be the result, you always get C. This means your expected payoff is always C. Okay. Now what I have. Okay. Okay. Now we will move to the what is the variance. Okay. Yeah. So what is the variance? We already discussed what is the variance.
Variance is just measurement of spread.
Yeah.
Also,
And for sample, what is the formula?
it's summation of xi minus x bar ka whole square x minus x bar ka whole square.
Okay. Same in this in case of what? Variance for probability sense is what? Expectation of x minus mu square. Okay. This is the variance of x. This is the formula. Okay. Now, so why we need variance? I think in descriptive statistics, you already know why we use variance.
So this is variance of an expectation value or just variation of this random variable.
Variance of x is this.
Okay, means
Expectation of x minus mu square.
okay.
Yeah. So see, variance is measure how your data spread over mean.
Yeah.
Yeah. So mean
Hmm.
is mu. Then what is x minus mu? What is the distance between xi and mu? Since this variance is always positive, because I am maybe this can be happen that some negative term and some positive term and variance becomes zero or variance become negative. Okay, that's why I am squaring this. Okay, so that all the quantities become what? Positive.
Okay.
Okay. Now what is the expectation of this? This is the variance. Okay, which is the same as expectation of this means what?
So
Xi minus mu square, how many times xi occur? Like this. Okay.
so we could have gone like only with the xi minus mu square with the regular variance. So why are we going for the expectation? I mean, plug in the expectation and then calculate the variance.
See, in that case, you are saying that why we are not using this now 1 by n minus 1 like this.
Yeah, yeah.
In that case, we have sample. Okay, we have all data. Then we are using that. In this case, we have no data. We have some random variable and some probability. Okay.
Okay.
So we can't use this.
Okay.
Okay. Same as that. In case of mean, we are using this. Right. But in case of random variable, we are not using this because we have no data. We have probability. That's why we are using what? Xi into probability of xi. In discrete sense, in continuous sense, we are using different thing. Okay. We are using this, right? Same
Okay,
as in case of,
this is our mu here.
yeah, this is our expectation now, and this is our mu. Okay, oh sorry, mu is mean. Okay, yeah. Okay, both are denoted by same symbol mu. Yeah, so what is variance? Variance of x is what? Expectation of x minus mu square. Okay, this is the formula. Now we can simplify this. How? See, expectation of, if we open this, which will we have? We get this expectation plus mu square minus 2x mu. Okay, so this is what we know. Expectation is linear, so we can separate this as x square plus expectation of mu square minus expectation of 2x mu. Okay, now this is what expectation of x square plus, I already discussed that expectation of constant is itself constant, and here we have constant. I can put constant outside the expectation. Okay, this is mu expectation of, this result you already know from your sample mean. Okay, and you can also do this in probability expectation. Why? Because it is what, 2xi mu probability of xi summation, like this summation. Now common these two things, what I get, 2 mu summation I equal to 1 to n xi probability of x taking xi, which is what, expectation of x. Okay, so this can be written like this. Okay, any doubt? Okay, now this is what, this is mu, right? So this is what, expectation of x square minus plus mu square minus 2 mu square. Now this is what, expectation of x square minus mu square. Any doubt? So our variance mu formula is what? Variance of x is expectation of x square minus expectation of x whole square. Okay, any doubt?
So why expectation of x is equal to mu?
Expectation of x, this is the expectation of x. We denote expectation of x by mu. This is just a notation you can use. So original formula is what? Original formula is variance of x is expectation of x minus expectation of x whole square, which is denoted by mu. Okay, this is just notation. Now new formula is what? Variation of x is expectation of x, sorry, x x square minus expectation of
Okay.
x to whole square. Okay, okay, now you can use this formula in examples. In case of if your random variable x, that two row die are rolled, and x is what, x sum of random outcome. Now you can find your variance. Okay, if you want, and you can also use this formula all the example which we discuss in this slide. Yeah, Someone raise hand. Yeah, you can ask. Now, so we know you can also find. So it is your homework. What is we already find what is the variance expectation of uniform random variable, uniform n, which is what, n plus 1 by 2. Now you find what is the variance of uniform random variable. Okay. Okay.
Sir, what's this expectation for a binomial?
Binomial expectation is np. You can find by geometric series npi p to the so you have n and p to the power 1 minus p to the power n minus. Yeah, you can solve this, and by this you can get this np.
Okay.
Uh, now what we have, now we know what is
Could
the
could you could you take like one or two example for this variance calculation here?
yeah, you can use that x is taking values. Okay, we will discuss standard problem like variance of which that uniform and all those things. Okay. Okay. Now variance of uniform n is the parameter. Now x is taking values 1, 2, 3, dot, 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 n. Then what is the value x square take? 1, 4, like this, n square. Now what is the expectation of x square? We already discussed, which is what? Xi square, probability of taking xi, x equal to be xi, right?
Yes, sir.
Okay. Yeah. Then this is what? This is what? This is your n square. Okay, I square. Sorry. I square, probability of xi taking value I. Sorry, xi, x taking value I, which is what? Summation I square, probability of x taking I is 1 by n. This is can be written as 1 by n summation I square, which is what? 1 by n. What is the formula for this? N plus 1,
And
n
into n
into
plus
n
1
plus
times
1
1
times
plus 1
2n plus 1
divided
divided
by.
by 6. Okay, now if you open this, you get this, and this is 2n plus 1 divided by 6. This is your variance for uniform. Okay. Oh, no, this is not uniform. Sorry. This is not variance. This is what? This is your expectation of x square. Now we have to find what? Expectation of x, which is what? N plus 1 divided by 2. What is the square? Square of this. Now what is the variance? Variance is this minus this. Then what is the variance? N plus 1 is 2n plus 1 divided by 6 minus n plus 1 square divided by 4, which is what? If I take common what? N plus 1 by 2, then what is, and 2n plus 1 by 3 minus n plus 1 by 2. Now solve this and you get what? If you solve this, you got you will get this n square minus 1, which is n plus 1 n minus 1. Okay. Any doubt? Just open this. Okay, I will open. N to 4n plus 2 minus 3n minus 3 divided by 6. What is the one? N minus 1 by 6. And what is this? This is n plus 1 by 2, which is same as this. Okay, these two things are same. Any doubt? Now you will solve for what? Geometric, no, hypergeometric and binomial. For Bernoulli, it is simple. Okay. Any doubt?
No, sir.
Okay. Then now we will see some property of expectation on and variance. So one property is what? One property is expectation of x plus y is expectation of x plus expectation of y. Okay. Second property is what? Expectation of constant is constant. Third is expectation of constant into x is constant expectation of x. These three are the properties of expectation. Now we have properties for variance. So variance of x plus y is what? Variance of x plus variance of y. Second property is variance of constant is what? 0. Third property is what? Variance of constant time x is what? Constant square variance of x. Okay. So from this you can say that what is the variance of x plus c, which is what? Variance of x plus variance of c, which is 0. Okay. By this you can also say what? What is variance of ax plus by, which is what? Variance of ax plus variance of by, which is what? This is a square variance of x plus b square variance of y. Okay. Any doubt?
No, sir.
Okay. We can discuss proof also. Okay. Let's see. So variance of ax plus b, if I prove this, then everything is everything, all other things already. Okay. So which is what? Very expectation of ax minus plus b minus expectation of ax plus b, right? Square, right? Or we can say this is what? Expectation. Yeah, this formula is what? Ax plus b square minus expectation of ax plus b whole square. Yeah, this will work. So this is what? This is expectation of a square x square plus b square plus 2abx. This is what? If I open this will be what? This is minus a expectation of x plus b whole square. Now this is what? This is a square expectation of x square plus b square plus 2ab expectation of x minus this is what? A square expectation of x square plus b square plus 2ab expectation of x. Now this is positive, this is negative because negative is here. These two term cancel, this is and this is cancelled, and what I will get this expectation of x square minus a square expectation of x to whole square. This is what? If I common a square, then the answer is x square minus expectation of x whole square. Then this is what? Variance of x, right? And this is a square, which is what? So variance of ax plus b is what? This. Okay. Now you can solve all other things by this. You can prove all. Okay. Now what we have other thing? Yeah, we have something is called independent random variable. So what is the independent random variable? So random variable x and y are independent when probability of x taking value in case of discrete sense, okay, value xi and y taking value yi or yj, it's up to y, equal to be what? Probability of x taking value
Xi.
xi into probability of y taking y value yi. Okay, this is the definition of what?
Independence.
Independence of two random variable. Okay, now um, now you can check that I have one experiment is what? Tossing, rolling a die two times, means rolling a two die. Then random variable is what? X is outcome in first die. In first die, and y is outcome in second die. These two random variable are independent. You can check. Okay. 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 Oh shit. I wrote some. Yeah. This is not true. Okay, sorry. This is true for independent. We will prove. So what is the firstly we will prove what is the variance of x plus y. So what is variance of x plus y? Variance of x plus y is expectation of x plus y square minus expectation of x plus y whole square, right? Then what is this? This is expectation of x square plus y square plus 2xy, which is minus, this is what? Expectation of x plus expectation of y whole square. Okay. Now this can be written as expectation of x square plus expectation of y square plus 2 expectation of xy. Now minus, this is what? Expectation of x square plus minus expectation of y square minus 2 expectation of x expectation of y. Okay. Now if I take these two together and these two together, then I will get variance of x plus variance of y. Then I have term this term is what? 2 expectation of x y minus 2 expectation of x into expectation of y. Okay. Now this is the variance of x plus y in general. Okay. Now there is a special case when x and y are independent. Okay, then what will happen? Then we will find this term. What is this? This is what expectation of xy is what? Summation xi y. This two summation I j xi y yj probability of x taking value xi and y taking value yj, right? Then this will be happen what? If I fix I think this proof is not in, is this in your book? I don't know, but we will discuss it. So if I fix I, then this is what? I is fixed, I can take out. Okay, firstly we have this. This is what? Since x and y are independent, then I can write like this: x equal to be xi into probability of y equal to be yi, right? Then if I is fixed, then this is fixed and this is fixed. Then I can take outside this. Then this is what? I xi probability of x equal to be xi, then summation j yj probability of y equal to be yj. This is what? This is expectation of y. Now expectation of y is constant always. Okay, so this is constant. This can be out. Okay, this is expect summation I xi probability of x equal to be xi from expectation of y. Since y is constant, then I can take outside. Then this is what? Expectation of y summation xi probability of x equal to be I. This is what? Expectation of x. This is expectation of y. So the important result is what? If x and y are independent, then expectation of x y is expectation of x into expectation of y. Okay, now if these two are equal, then by this formula, by putting this is equal to be this, then this term cancel. Then what is the variance of x plus y? Equal to variance of x plus variance of y. Okay, any doubt in this? Any doubt?
So why are we treating this y as independent? I mean, y as constant, sorry, y as constant.
Where y is constant?
You considered y to be constant now when you
No, x as the fixed value.
okay.
Yeah, I take x as the fixed value. Since
Mm,
summation is going to I and j both, then for I equal to be 1, j is no, there is no constant on j. Then put I equal to be 1 here, 1 here. J is going from where? 1 to infinity, wherever.
mm,
So whatever we have range, then this is equal to be this, we know, since x and y are independent by definition.
okay, okay.
Yeah.
Mm,
Then since x is fixed, then I can take x outside. Since
mm,
x is fixed, then probability of x equal to be x is also fixed. Then I can take also it's outside this sum, jth sum. Then this sum is what? This sum is expectation of y,
mm.
right?
Yes, sir.
Now, if this is expectation of y, then now we know what is expectation of y is a constant thing. It give a
Yes.
constant value. Then
Mm,
I can put this out of this summation. Then what is this? This is the expectation of x. Then this is and now we got the form. Okay.
Yeah, got it, sir.
Yeah. So what are the properties we have? So expectation of sum is what? Sum of expectation, and expectation of constant is what? Constant. And expectation of constant time x is what? Constant time expectation of x. These properties are important. Now for variance, what we have? For, okay, this thing is called what? This is called covariance, this term. Okay, you will discuss, I think you will see in later chapter. Okay. Okay, now variance of x plus y is we derive that formula. What is the formula? Variance of x plus variance of y, and then we have 2 expectation of xy minus expectation of x into expectation of y. Okay, now variance of ax is what? A square variance of x. You can prove this, and I already proved this thing. Variance of ax plus b is what? I already proved this is a square variance of x. Now if b is 0, then this will be, okay? And variance of b is what? Variance of b is 0. Okay, all the properties, if x and y are independent, then variance of x plus y is variance of x plus variance of. Okay,
So,
that's, yeah,
so what is that 2 of expectation of xy minus expectation of x and x?
this term,
Yeah,
this is nothing.
or plus.
We derived this formula, no? Variance of x plus y is what?
Mhm.
We derived this formula.
Okay,
Yeah,
okay.
same formula is yeah, this variance of. Okay, any doubt? Try to solve example for these two these properties. They, in, I think in slide they gave some example. In your problems here, I think you have some problems. Okay, so you understand what is the independent of random variable, no?
Yes, sir.
Yeah. Okay. Okay, that's it.
So, I have like one of the previous doubts.
Okay.
During quiz, before the quiz review that
Hmm.
ma'am take, Professor Usha ma'am take, there was a topic of probability trees.
Okay.
Uh, like explain, or due to time constraint, it was not explained in detail. Could you please explain the topic, please?
Okay. I think you are saying about this. So probability trees is what you have some. If I am correct, then you firstly toss a coin, you get head, tail. Then you again toss coin, you get head, tail, you get head. Then okay, so you got what? Head, 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 tail. In this case, you get what? Tail, head, and tail, tail. Now same like this. Then what is the probability? Now if probability of head is this, okay, and probability of tail is 1 minus p, then what is the probability of this happening? This is p into p. And what is the probability of this happening? First head probability of p into 1 minus p. Probability of this same. So this is 2 times. And this is what? 1 minus p. Am I right? Or there is another, there is other probability, this is a probability tree. Is this probability tree or
Sir, it seems the same that you have shown, but
okay.
like the notations were used a bit different in the slides.
Which slide? Can you share a screenshot?
Yeah, just a second,
Yeah.
please. Or should I share you? Let me share you the link of the professor's slide itself. I've shared in the chat. It's from the page number. Just a second.
Just it.
Page number 72.
Which one? There are two
First, sir.
permutation and combination.
Yeah. From page number 72 onwards.
72.
Yeah.
So, okay. Yeah. Same thing. Is this slide is visible?
Yes, sir. It's visible.
Yeah. So if you see, the in first toss we have what? Head and tail. Okay.
Okay.
Now, if I again toss, then what are the result? First toss is head, second toss is head, first toss head, second toss is tail, first
Mm.
toss tail, second tail, toss head, and tail. Like this.
Yeah.
Then if I write probability for this, probability of head is what? 0.5.
Mm.
Probability of head again is what? 0.5, 0.5. All these are 0.5. Okay.
Mm.
Now, what is the probability that two head are occur? This means first head 0.5, which is the you can relate this by independent of random variable or
Okay.
independent event. So
Mm.
see, x1, assume that x is your what? First head, x, and y is first is your first outcome and second y is your second outcome. So
Mm.
both are, I already gave you an exercise that these two random variable are independent. Then
Mm.
what is the probability of that x take value 1? Assume that head is denote 1 is, and y is take value 1. Probability of x take value 1 and y take value 1 is what? Probability of x take value 1 into probability of y take value 1.
Yes,
Right?
sir. Yeah.
Then this give you what? This thing. Head thing. Same like head tail thing. Same like tail head and tail head. This means multiply this and this two. Assume that if this is 0.3 and this is 0.7. That's it. Yeah. So in this diagram, this is P, this is P, this is 1 minus P. Means probability of head is P, probability of tail is 1 minus P. Then what is the probability for head? Head in by
That's
this, if you go by this path, then you get head, right?
yeah.
Then which are the thing you get? P and P, which is what? P into P. What
Mm.
is the probability of head tail? Head tail is what? P into this, right?
Mm.
So
Yes,
head
sir.
tail is P 1 minus P. Similarly, what is tail head? It is this and this, right?
Yes, sir.
Yeah, this is 1 minus P into P. And what is tail? This path, right? Now we will see there is some another example. So pick a ball from the bag of 3 black and 4 white ball. Okay. Bag one. Okay. Okay. Now see. So so you have bag which contain what? 3 black and 4 white. Okay. Yeah. No. 3 black. Yeah.
So this example was a bit confusing for me completely, because if the first ball is black, then the we should decrease the count for the black ball in the back too.
Just
Uh,
what is the where is the question?
so question is not included. It's just this
Okay.
line.
Oh, just yeah. So in bag one we have 4 white ball and 3 black ball. In bag two what we have? 3 white and 6 picking a ball from a bag. Picking a ball from a
So
bag.
from my understanding, what could have happened
Okay,
is
okay, just a second. We have two bags. And in bag one, we have four white ball, three black ball. In bag two, no, 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 no. Yeah, your point of view, you are saying something.
So what I understood was that it's from the bag one we have picked one black ball or a white ball out. Okay.
Yeah.
So when this bag transforms, that's let's label as state two. That is bag two. Now after some changes, it becomes a bag two. So the count of the ball that we have drawn out should have decreased, but it's like transforming in some another way. So that create like hurdle for me.
I think we have two bags. Okay. I think we have two bags and pick a ball from pick a ball, two bags. So bag one contains four white and three black, and black two contain three white and
Is it the case that the bag two has three white and five black balls, and we are picking one ball from bag one and putting that in bag two?
but where they mention that bag two contain three.
They haven't, sir.
Just a second. So what the total 600 is probability of P1 bag 150. Then we choose one ball and then 5.9 to 1. There is no question for this.
No, sir, it was not included. It was a revision slide for uh, this before the quiz two, and this topic probability tree. There was no pre video before this slides. So
Yes.
yeah.
So there is one bag which contains four white and three black, and probability of choosing black ball is 3 by 7. Yeah, white ball is 4 by 7. Then if I go to the black two, what is the probability that black two which contain which contain if we do if we say three white ball, five black ball, black ball from both. B1 is choosing black. B2 is choosing black ball, black two. I think if there are three white ball in bag two and five white ball black ball in bag two, then choosing a black ball from bag one and one black ball from bag two is what? I choose one black ball from which is 3 by 7. Then I go to these two are not same. 6 by 5.
Sir, could you
So
repeat
with
the question? What's the doubt?
I also don't know what is the question. There is just a tree. So
I don't know, sir, how to construct this trees. For this
so
previous example, I got it that you explained the head and
maybe
tail.
ma'am explain what is the question.
No, sir,
Like,
ma'am did not.
why there are back twos, like two backs of back twos?
Ma'am skipped it during that time. Ma'am said that due to time constraint, go through it. You will understand it, but it's still bothering me after like more than a week.
How this is choosing a bag? Pick a ball from two bags. Ball from two bags. One ball from a ball. Yeah, one ball.
Sir, there might be like it must be back three. Like there is any mistake over.
No, 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 no. Then there is no decision to it. So if he is choosing bag one with probability this, choosing a black ball from bag one with probability this, choosing a bag two is 5 by 9. Then why this is 6 by 9? If he is choosing for only one ball, then what is the probability that choosing a one bag? That will, I don't know. Okay. Okay. So I also don't know this. What is this example? But yeah, I will uh, send this question to Prasant sir because I think maybe this is today is my last class maybe. Okay.
So, will you not be taking any further classes this term?
Yeah.
Sir,
Yeah.
I had one doubt in quiz too. Like, if you can open
Okay.
the.
Yeah, you can ask.
Uh, just a second, sir.
Yes.
So I have pasted the question.
Where?
Uh, so if you can see the question, I pasted in the chat.
Yeah. Yeah, I have Notebook, but I'm not using. Why this is not open?
Or else I have pasted the question paper link.
Okay, yeah. Yeah.
If you can just open the page number 44.
Okay. Yeah. Which exam? There are
Foundation.
3 slides.
Yeah, any. Yeah, first, click first one, sir. Yeah, 44 page number.
Which page
Just
number?
type direct. 44. Just
Okay.
type it towards sir.
Yeah. Yeah.
Scroll down, sir. Yeah, this one, sir.
This one in the school function.
Yeah.
Yeah.
So, sir, the approach which I applied, like first I placed the 3 and 1.
Yeah.
The
First,
4
I
minus
have to
1.
read this question. Okay. Let's see. What are the other subsequent questions? Okay, this is the question. Where are the sub questions?
And these are some questions, sir. Choose the correct option for following.
Okay, this
Below
one.
ones are sub questions, sir. There are total 3 sub questions, I think.
But where?
The part which I don't understand, sir, just like
No,
we can
no.
arrange.
Firstly, where are the no? I am not. Where are the sub questions? This is question number
Yeah,
3.
sir, like we can select this like simultaneously without replacement and
Okay.
scroll down, sir.
Yeah.
Just
Okay,
scroll down.
selection. Yeah, these are the questions. Yeah.
And if you scroll down, order matters, permutation used, and like find the ways of this part which I want to
This
discuss. Like find the number of the ways in which the performance can be arranged in a circular order, such that node
does
two.
that node 2 let me put it together. Okay.
Like, shall I tell my approach, sir?
Yeah, you can tell.
So we can arrange the remaining four members in 4 minus 1 factorial 4 minus 1 divided by 2 factorial ways, sir.
What was just can you?
If you can see the questions, I will tell according to. Like they were asked like no two islets should not sit together,
Yeah.
sir.
Yeah.
So what we will do, we will arrange first that 3 and
3.
1
Yeah.
4 minus
Oh,
1 factorial ways.
yeah.
So it would be 3,
3
sir.
factorial, which is
3,
6.
yeah, sir. 3 divided 4 minus 1 divided by 2 factorial ways.
Why?
Like there are 4 members in circular, we can arrange those 4 members in 4 minus 1.
Yeah,
3.
it
We
is
will
3
first
factorial.
arrange like these two should not sit together, na, sir. So
No,
basically,
no,
we
no.
will
Just a
arrange
second. Just a
the.
second. We have to. Okay, just a second.
Yes.
Where is yeah. You have 4 member. You want to arrange in circular manner. That this is 3 factorial. Okay.
Yeah.
Okay. Now you how many gaps are there?
Yes,
1,
sir.
2,
We have
3,
4 places, 4
4.
C2.
Yeah. So 4C2. 4C2.
Oh, sir.
Then
Okay. And we
how
can
many ways
arrange
you
those
can?
two factorial, 2 factorial.
Yeah. Okay.
Okay, sir. Just a second. Okay. The mistake what I did, I divided that 3 factorial into 4 minus 3 divided by 2.
Yeah.
So basically, when we have to divide that by two, and when we haven't, so like there was question which I practiced for this quiz two was like I was practiced that one question was on necklace. So
Oh,
there we have divided it by two.
yeah.
So here we should not divide it by two, sir.
In necklace case, if you see the necklace from right to left and left to right,
Ah, yeah,
like
got it,
same.
got it.
That's why we
Yeah,
divide.
yeah, yeah.
Yeah,
Yeah, here it will be different.
yeah. You are just sitting. You can't flip the necklace like this, like the necklace, na?
yeah, yeah,
Yeah,
that was a mistake. Okay, sir.
yeah. I already discussed this before. Okay, that's it.
Thank you, sir.